Good afternoon. So my name is Aoyu Wu from Harvard University, and I just graduated from the Hong Kong University of Science and Technology. So welcome to our panel. So today we will talk about visual analytics, especially ground challenges in visual analytics. It's our great pleasure to invite some of the experts in our field, including Professor Min Chen, Professor Shixia Liu, Professor Daniel Kane, Ross Michowski, Sylvia Miaya, and Hendrik Strobert. And I also would like to give acknowledgement for my previous supervisor, Professor Huamin Qu, for his very insightful suggestion on our panel. So visual analytics systems are basically software that apply visual analytics techniques for solving an application-driven problem. And it has contributed many successful stories to many wide-ranging domains such as XAI, sports, urban analytics. And it has also become a very important research topic in our field. For example, in last year's visualization conference, we have about 27% of publications about visual analytics. Despite of those successes, we often hear many provoking questions from our end users, from the peer researchers, as well as researchers from outfield. For example, people frequently asking what can we learn from visualization analytic system beyond solving the domain-specific problem. And some people are also criticizing the evaluation, saying that our evaluation method is very informal and which is common in many submissions. And more importantly, so what are our underlying research methodology and theory? So what are the bases that forms of our field? So in this panel, we will invite 6 panelists to give a position statement. And after that, we will spend the remaining time in Q&A session. And the Q&A session, please put in, sorry for typos, it should be slider. So we will monitor that. And let's welcome Professor Min Chen for his position statement. Professor Min Chen is currently a professor of scientific visualization at Oxford University and a fellow of Pembroke College. He has co-authored over 200 publications, including his recent contribution in important areas such as theory of visualization. He has actively served to the research community, such as paper co-chairs for IEEE VIS 27 and 8, IEEE VAS 2014 and 15, and the associate editor-in-chief of IEEE TVCG. Let's welcome Professor Min Chen.
Thank you very much. Thank you. And so I'm going to be quick, and we have a 5 minutes limit. So I'm going to propose a grand challenge for creating a visual analytics encyclopedia A to Z. So about 2002, the US and the UK had 2 workshops on grand challenges in computer science. I was lucky enough to attend the UK one, and I learned a lot from the grand challenge proposed at that time. And one piece of knowledge I acquired from Sir Tony Hall, and he was among a few people who attended both workshops, and he proposed some sort of a desirable feature for specifying a grand challenge. And I'm not going to detail to talk about all 17, particularly he mentioned that a grand challenge must be testable. In other words, it's easy to say it's succeeded or failed. And he set up an ideal time frame. He said probably 10 to 15 years time. And I mean, around 2007, so sounds like old, just going backwards all the time. And so Dorchester had a big debate on the article written by our famous Bill Lorenzen on the death of visualization. And I dug out my own slides talk. I remember the slides in the conclusion slides, and I showed that picture, made the statement to say, this is not a dying patient. and ideally the problems in our users' workflow and are our patients. And the one thing I'm using that particular cartoon to illustrate at the moment, we're actually not necessarily a very good doctors because we rely heavily on the intuitive gut feeling in solving our users' problem. So, of course, over the years, there are processes being made, and we have a requirement analysis, and we analyze what do user want. We're usually written down in our section 3 as R1, R2, R3, and so on. And we may have task analysis, we write them down as a T1, T2, T3. And just a few days ago, Ranko and Tufts University proposed that we should try to understand the user's hypothesis, and we may be listed as H1, S2. And also, David Ebert and I wrote a paper a few years ago as to looking into the problem in users' workflow, and we may be written as a symptom 1 and a symptom 2, and so on. And if we think about the process involving that, from the right to the left, and you can see that the gradually increased demand on the kind of the knowledge and the skill of the visualization or visual analytics scientists in terms of their ability to observe the problem, ability to diagnostically analyze the problem, and their knowledge about solving the problem. I here emphasize the collective knowledge, which ideally we should use, just like in medicine, to help solve the patient's problem. Very quickly, you may read the paper, and in 2019, and David and I, and you all know David by now, and the symptom, we analyzed the symptom and the causes and the remedies and the side effects in the visual analytics workflow. And the aim was to analyze the problem, try to using, for example, statistics to solve the visualization problem, or visualization to solve the statistic problem. And there are many kind of a trade-off between different components. The aim is to optimize the workflow. And we analyzed the 3 case studies in that paper, but recently we also started applying to the real problem. For example, in the music machine learning paper, my student could present, and on Thursday, we listed the symptom and the cause and the remedy and the side effects explicitly by analyzing the problem of existing solution and then try to solve it in a way. In another piece of work, and we, at the beginning of the COVID, and quite a few visualization colleagues with doubts the question why we display big numbers in the dashboard, because it's not visualization and it's very partial. And we also conducted a study to look into the problem to say, if we're not using this big number, what other sort of a solution could be? Eventually, we go around the analyze using the graph on the right-hand side. We come back to the solution to say, actually display the big number happen to be the best solution in this case. So unfortunately, due to the space, that particular part of the work was not featured in the paper itself. So in summary, ideally, and we can collecting all the symptoms, causes, and the remedies, and from our sort of existing work by analyze all successful visualization papers we can talk about, and we probably need to go through it. So I read many papers and collecting those kind of analysis, cluster them, analyze them, and hopefully we can edit a book or a web page called Visual Analytics Encyclopedia A to Z. Thank you very much.
Thanks, Professor Min Chen, for his very insightful suggestion. So I think we do need some work that collecting our existing visual analytics system so as to develop some general knowledge from this very ad hoc system that to move our field move forward more vibrantly. So unfortunately, Professor Xiaoliu cannot join us today because of some urgent family affairs. So next we will have Professor Daniel Kim for his position statement. Professor Daniel Kim is analysis and information visualization research for more than 25 years and developed a number of novel VA techniques for large data sets. He has been program co-chair of the IEEE InfoVis and the VAST conference. Professor Chen is a recipient of IEEE VGTC 2011 Visualization Technical Achievement Award. Let's welcome Professor Chen.
Yeah. Thank you for the introduction, and thanks, Ming, for your statement. I want to keep my statement very brief because I think there are many challenges that we do have in our field. And like you mentioned the theory of visual analytics that was kind of from the beginning on the agenda. And we have made some progress, but I think we still have that as a big challenge to have that theory. Let's take the example like the keynote at the BDS that Remco did a few days ago. And he was talking about his hypothesis space, how he defines it. I think there's plenty of stuff that we still need to do there because it's by no means complete in the sense that it covers all what we do in exploratory analysis. There we need a much bigger theory. And probably this is the most interesting part that we still haven't covered. Like all the simple hypotheses, they are already statistically covered. And if we take Min Chen's picture of all the different parts of the pipeline, in many of these spots, we have a first paper, yeah, but it's not the complete picture by no means that is covering all the applications. So we don't have a theory of visual analytics, I would claim, despite all the nice stuff that Remco and Min and other people have done. I don't want to devalue that. I just wanted to say there's much more needed to have it comprehensive in a way that it covers the applications that we are dealing with in everyday life. Evaluation was mentioned. I guess we all agree evaluation is a challenge, is particular in visual analytics. And I would like to stress it's systems that we evaluate. It's not a visual design in itself. There are many different visual decisions that we do designing our system, but a system evaluation, you can't do user studies for systems evaluations. You have like 100 or 1,000 decisions that you make in your system design. Each of them would require a user study, and of course the combination of all would require an exponential number of user studies, and nobody is ever going to do that because it doesn't make sense. And you wouldn't have the experts to evaluate them anyway. So no, that is not the solution. That may be the solution for a very little decision, but I would claim visual analytics, most of the time, user study is not the solution. And that means we need to find something else, which we all struggle with. If you have a couple of experts, you are happy that you work with them and you get real feedback, but that's much harder sell and pair analytics and so on. There are things proposed. I'm not saying we are starting from zero, but we all struggle with that when we want to get a paper published here. Why didn't you do a user study for this? And you say, no, a user study wouldn't really help, wouldn't tell me anything useful, at least for the bigger picture of the system. So I think that is still a very important challenge that we face, in particular in our field of visual analytics. Generalizability, reproducibility. We have the nice thing that we work with real applications. We have a real application problem and we want to solve it, which is great. If we do that, it's not clear whether anybody else in the world needs something similar. And that's another thing that we struggle with when we publish it here. People want to have generalizability, reproducibility, which if you solve that problem and really made that person or that application happy, doesn't mean that this is already done. And like that's again something that is particularly difficult for visual analytics. We tend to start with a real application, real world problem. We want to solve it. And that makes us get into that trap at some point. Is it really generalizability? In particular, if you build a system, you're not developing one technique, but a system. And finally, I think there is integration of all this AI, machine learning stuff in our systems. We don't want to do things interactively, visually, if it can be done by some automated means. And that may mean for an application problem that you end up working with them and the machine learning does 95 or 99% of the work, and you just need to show a few numbers or whatever to the user and you're done with the problem. And you won't get a WIS paper, right? There is no way to put that unless you artificially put some visuals in and interaction in. There are applications where visualization is not the means to the end. You may run into that problem. If you're working in visual analytics, you may find out that the visual part is the least important part. But you still solve the problem. I'm not saying it's not worthwhile doing. I'm just saying you may run into the problem that there is no new visualization needed, there is not too much interaction needed, because application people are usually happy if they don't have to interact less, right? Because that takes time, and human time is expensive. So the less interaction, the better. The less complicated visualization, the better. And this, of course, makes it hard to get a WIS paper, right? So we are struggling with that problem, and I think that is one of the challenges of the field. You can say, okay, we have to select the right applications where there is a real need for innovative visualizations. But I would argue, in many cases, in particular in visual analytics, you just combine existing visualizations into a system. It's most of the time, I would say, now maybe 10, 15 years ago, it was different. There we had still room for many new visualizations. Now it's usually not a completely novel visual design, because we have explored the space of visual designs already quite a bit. And so we are recombining and taking the good pieces, putting them together in a nice interactive way. And that is kind of what is really core to our field. And that is usually not appreciated as much by reviewers. And if you're working visual analysts, you have run into that problem, I'm pretty sure. And that means, what are we going to do about it? Is it not part of this conference? Of course it is part of this conference, but some parts are really moving to the edge. If there's not a visualization that is really core, yeah, then it may not be published here. And I think that is one of the challenges that we do have in our field. I don't know, my time is probably up. I wanted to show an example, but like maybe I do switch to a live demo quickly. Like we developed a visualization system, a visual analysis system for Corona data in Germany. And this is a live system, so this is a live demo. I can really go on here, it's interactive, and I can click on any of the counties and get all the data shown here for any of the counties. And you get all the detailed information of all the Corona crisis that is out there. This is an age distribution down here of the Corona cases, and you can go any time here. You see the young people were first here, then the older ones. The later waves, like the current wave, is more the older people, not the young ones, and so on. You get plenty of information, and this tool allows you to go back and you see the sequence. Now it's not too bad, and you have analysis components in here, like the trend analysis that's showing it's currently going down slightly, and so on and so forth. You can go in and get that for any county. You can aggregate it to district level data, and you see all the predictions also for the districts. You can go on the state level, get the same for the whole state, all this information. It's now aggregated, so it takes a few seconds. You see the intensive care unit changes and so on. And you can even go down and go really on the hospital level. And just need to do a couple of clicks here to now have every single hospital in Germany with the intensive care unit. And that is the current data of today, this morning reported by every single hospital. And you can go in and even see here the different hospitals here of this particular one. You see the development over the last days. So the low care is full now and so on, and the ECMO is available and so on. So you get all that information and you can go into your neighborhood and see whatever you may see here. Just as an example of a system that is running, and there's some new visuals, but it's mostly visuals that are already out there, line charts, heat maps, and so on. And like we did try to publish it here, it wasn't accepted. And it's a live system, you can work, it's like plenty of technology behind it, it's scalable, anybody can access it, like thousands of concurrent users can use it. It's like many components. It's quite a bit of effort putting it together, collecting all the data and so on. But it's not good enough for the conference here. So the question is that also a problem? And what can we do about it? With that, I would leave it. Thank you.
Thank you, Professor Kim. So I think that's really a critical problem about our research review process. So what values should we consider when we're evaluating these systems? The local visualization design, or better evaluation, or better integration between visualization and interactive AI algorithm. So, and next we will have Professor Sylvia Mixia for her position statement. Professor Sylvia Mixia is a university professor and head of research division Visual Analytics, which is part of the TUV. She has acquired and been involved in several national and international basic and applied research projects. She has served on various program committees of international scientific conference, such as paper co-chairs of the IEEE VAST 2010 and 2011 and 2020. He has also acted at various strategic and guiding committees, such as the VAST Steering Committee, the VIS Exclusive Committee, and in 2020 she was induced into the IEEE visualization deck. So let's welcome Professor Sylvia Mixia for joining us online.
Thank you very much for the invitation. Do you see my slides and can you hear me?
Yes, I can.
Great, great. I want also to talk about the challenges and opportunities, and I want to focus particular on the process of visual analytics. Sorry. And this is an old chart, what was presented by Daniel Keim many years, not many, but a couple of years ago, where we tried to formalize what is the visual analytics process, that we start with the data, taking visualization, coming to knowledge, or doing it by the model part. And the most important part was that we use visualization for model building, and we use models for visualization, and we were focusing on the parameter refinement of the models and the interactions. We presented, as Daniel Keim already mentioned, a couple of many visualizations. This is my own research field, what I presented here. But the main problem or the main challenge here is that currently our users, visual analytics users, are somehow overwhelmed by the many visualizations which are available, the many algorithms which are available, and also the different parameters are available. And Min and Daniel mentioned that we need some kind of theory, and I also want to propose that we need some kind of help to guide the users on, and help the users to tackle these challenging problems. And my challenge is what I want to address here is, first of all, we need kind of conceptual model of visual analytics where we can go two pathways to tackle this. On the one hand side, we need some kind of knowledge assistant. What I mean by knowledge assistant, that you have a lot of background knowledge about the domain, and you have a lot of implicit and explicit knowledge, and you really need to model this to come up with better visualizations. The next thing is what I think what I would like to propose, what is needed is you need to enhance visual analytics solution with guidance. What do I mean when I talk about guidance? Guidance is a computer-assisted process that aims to actively resolve a knowledge gap and encountered by the users during an interactive visual analytic sessions. Here, again, the most important issue is that you are dealing with a process, you're dealing with a knowledge gap, and you try to interactively solve this knowledge gap with different dimensions. And we have proposed in my group also a very enhanced Van Beek's model about the value visualization, and enhance this about the guidance concepts to handle different kind of guidance like orienting, directing, and prescribing. I don't want to explain you this model in detail, but it's one approach to guide the user on different levels. The most important issue here is that we are talking about a mixed initiative process. On the one hand, we have the users who can explore the knowledge gap. On the other side, you have the user wants to decide about the next steps. On the other side, you have the system who can react on the knowledge gap and can give you some cues. And the solution what we are working on, which is not solved yet, but what we are working on, is that you really need to integrate both components, the user and the system, to really provide efficient and effective guidance. This brings me to the next concept. So the next problem what we have, we are talking about evaluation. Daniel talked about evaluation, Min talked about evaluation. We also designed a framework. And if you design guidance enriched visualization, you also need to tackle particular quality criteria. For example, it needs to be available. This means guidance is there for you, or it needs to be trustworthy. Guidance will help you, or it needs to be adaptive. Guidance will adapt to the particular situation to solve this knowledge gap. It needs to be controllable in a sense. Guidance can be tuned, if necessary. And the last one, but most important stuff is it should be non-disruptive. This means guidance will not annoy or mislead you. These are qualitative criteria. You need to operationalize them, and you need really to structure them and evaluate them according to your particular needs. And this is an interactive process. There are other models that were provided, for example, data user tasks, or Remco proposed on Sunday another proposal how to tackle it with hypotheses. We are tackling this with tasks and users. There are the nested model from Tamara Munzner, which also tried to capture all the different dimensions, but still how to design the whole process is still an open challenge. This is my first challenge towards a conceptual model for visual analytics. My second one is there are still a couple of aspects which are not tackled appropriately. One is our data is the data quality. We need to assess our data quality before we can really provide good visual analytic methods or solutions. We need to be aware about the data provenance if you want to analyze the data, and we have to capture a lot of uncertainty on the temporal and on the data dimension. And last, we need a kind of science of interaction. We are interacting, but mostly there are ad hoc interactions. The next aspect, which was also addressed by other speakers, is by Daniel and Min, was we need to have a more appropriate visualization techniques. We are dealing with processes, therefore the usual quantitative or qualitative approaches or the approaches from HCI are not really applicable for these complex visual analytic solutions. One idea is heuristics or multiple steps. I'm currently a fan of Meli Wall's IST heuristics, which tries to help you to evaluate the visualization according to insights, time, essence, and confidence. But I think we are not there to have a good evaluation concept. And my last issue, everybody is currently talking about explainability, explainable. And it's mostly done in the AI field, but we could also use our particular techniques to come up with faithful explanation, rational reconstructions, constructive and social ones. But still, what is a good quality of evaluation is still an open issue. I want to, and also, sorry, I missed a couple of application domains should also drive our stuff. I need to thank a lot of people, and I need to make last one advertise We wrote a book about time visualization, and we have finalized our second extended version, which will be published next year. Thank you very much.
And thank Professor Miksha for her very insightful discussion. So I think one trend in our field is that our systems are becoming more and more complex. So in this trend, we really need to think about how can we provide guidance to the users to support their exploration. And next we will have Professor Rose Machevsky for his position statement. Professor Rose Machevsky is a professor at Arizona State University in the School of Computing and Augmented Intelligence, and the director of the Center of Accelerating Operational Efficiency, which is a department of Homeland Security Center of Excellence. His primary research interests are in the area of geographic visualization and the visual analytics focusing on Homeland Security, public health, social media, criminal incident reports, and the food, energy, water nexus. He has served on the organization committees for the IEEE VAST conference and the Eurovis conference, and he currently serves as the co-chair of the Visualization Exclusive Committee. Let's welcome.
Oh, thanks everybody. So one of the dangers to giving your position at the end is that everybody already gave your position for you. So I'll try to be brief, but I think all the things that have been talked about already in terms of evaluation, guidance, explainability are all sorts of key things that I'm really interested in. I think are still open challenges for the community. And we've talked about this for a long time. We've had these stats before. Ongoing data deluge. May 2019, 500 hours of new video every minute of the day. You can't see all the cat videos that are going to be posted on YouTube anymore. It's just not possible. Too many hours at it every day. Walmart has $36 million an hour in sales transactions. There's 235 terabytes of the Library of Congress as of April 2011. 74 terabytes of that could be downloaded for free if you want. And years ago, Dr. Stasko had this in his lecture where information is gushing towards your brain like a fire hose aimed at a teacup. But I think an important thing to remember in visualization is we also need to have fun in the data deluge. There's so much data, so many interesting problems, but this leads to lots of sort of one-off systems and thinking about how to evaluate these. And partly what I want to talk about with explainability is when we make these visual analytics systems, we often say, well, we need a domain expert because they bring domain knowledge to the problem, and that domain knowledge is hard to capture in the data. But this means it's also sometimes hard to explain and capture their analytic process. Here's a simple example of exploring food preferences in Twitter. So looking at food preferences for the word dairy, and we can say, okay, dairy is, let's just pick some keywords, milk, kefir, yogurt, etc. You can look at what are the main things that people talk about when they talk about dairy. And if you're not from the US, Dairy Queen is a fast food restaurant where you go and you get a hamburger and a shake. And if we start looking at some of these trends, we can see, okay, what state in the US are they talking about other words with milk? So you can see where people talk about chocolate milk, almond milk, cereal milk, milk tea. And so we might say, well, why is this particular state of California talk about milk tea so much? And you have to bring in your own domain expertise and own explanation as to why this is here. We could say, well, we can go look at other states. We could go to Wikipedia. We could try to infer why this is. But capturing all those things is still really hard in these visual analytics systems. Of course, you can look at the distribution of people talking about Dairy Queen and dairy farmers. And you can see that Indy, Ohio is talking a lot about dairy farmers. Does anybody want to guess why Vermont doesn't talk about Dairy Queen? Yeah, it doesn't exist there. There's no Dairy Queens in Vermont. It's the only state in the US without Dairy Queen. So if you're from Vermont, you know that. If you're not from Vermont, you have no reason to know that. But it's a weird outlier in the data that requires this weird domain knowledge. They plan to expand there in 2016. I'm not sure that ever happened. But capturing data from weird and interesting places lets us think about other sorts of problems. So I work with Dr. Ariana Medell on urban climate informatics, and we can do things like, well, we have all this Google Street View imagery. So why can't we take this Google Street View imagery and turn this into pictures of the sky to capture sky view factor and put these into climate equations to determine thermal comfort factor in a particular location. And you can start building these very high detail local resolution models that again may require some interesting explanations. And then you can do fun things like I could build an app and say, how do I walk from my building on Arizona State University campus to another building at 9 a.m. may be different than how I want to walk at 2 p.m., depending where the sun is. I may say, I'm willing to walk an extra block if I can stay in the shade because it's really hot in Arizona, 110 degrees. But then if I write a news article about this, I get comments like, even my dog's smart enough to walk in the shade. Why do we need to do this? But you can start thinking about where to plant trees, and you can start building out these different sorts of explanations. But then it goes to, okay, I want to put a bus stop here, but what time of day are the riders going to take the bus stop? What angle should I focus this? How do I start building these different models and different sorts of things to explain what I'm seeing in the data? Years ago, I talked about how we can have fun by mining the white pages. So we can look and see where all the Montagues in the US are located. And this word cloud shows what other names have similar spatial distributions to Montagues. So you have Wilson is very similar to those. You can look at Majeski land in the US and you might say, why does Majeski have this spatial pattern? If you know anything about Polish names in the US, this is the Polish belt in the US. If I put a French name up there, you want to guess where the French names occur? Louisiana. If I put the Scandinavian names, it's Minnesota. So you have these very interesting pockets of things. I can go on Zillow. Once I have your address from the white pages, I can go on Zillow and see how much your houses were. So I can get also the income distribution for Ross, for all the Majeskis in the US. I can see where everybody with the first name of Ross lives and see how common Ross is. I can guess how old Ross is with, I add data from the US Census Bureau. So my mom was pretty much right on track with the curve there. And you can see the secondary spike there in the 1990s from Friends. But again, this all requires this sort of secondhand knowledge for me to tell you a story about this data. And what we see a lot in visual analytics is people taking some really interesting complex models. Like let's say that I want to model urban climate informatics, but I want to put this in conjunction with a social and economic status model. How do I start linking these models together? We can do this for oil spill and say, okay, there's a blowout in the Gulf of Mexico, but now I need a model for doing boat cleanup and having an economic model for where I need to clean up oil so that it doesn't land in a particular portion of the country, and how do I protect different species, and what are my trade-offs between this multi-objective criteria. So I feel like I've been talking a long time, but I'm probably just talking fast. I'm sorry, I had some stuff that came up right before this that caused me some problems. So apologize to everybody for being a minute late here, but we talk about explainable AI all the time, but we also need explainable visual analytics. And the community's talked about this a lot with the idea of provenance. How do we track this provenance? But how do I explain my analytic process in a way where somebody else can capture that? And let alone if I can sort of explain this, can I start using these analytic processes to train machine learning models for guidance? Can I help guide novices by capturing all this data? But if I have these very specific one-off problems, for example, like the healthcare work that Daniel was talking about, there may be one healthcare practitioner in the state of Indiana when I was doing work with the State Department of Health. So how do I capture enough data to be able to sort of explain their analytical process? How do I capture these things for provenance? The visual analytics community for years talked about opening up the black boxes, right? We said we want to open these black boxes to improve model saliency. And years ago, I commented on this about, should we even open the black box? If I'm letting people twiddle these knobs and dials without any idea of what they do just to make my model better, are they just overfitting? Are they fitting the model to their preconceived notions? And I think it's still an open question in the visual analytics community about how much humans should be in this AI modeling loop. We talk about auto ML, but how much auto? How much human in the loop? Libraries make it really easy to do. Sorry, I put spatial analysis, but I just meant machine learning here. I do a lot of spatial stuff, as you can see from all my maps. So sometimes I think that way. But just because I can apply machine learning to this thing and I can stick anything in Python and say, here, run deep learning on these images and see what comes out, doesn't mean that I should. And I talked briefly about these model compositions, but it's really hard to take these different models and plug and play them together in any meaningful way, and you have to have that expertise. And while this isn't necessarily a challenge for visual analytics, this is a place that's ripe for sort of thinking about this, where there's people that want to think about, you have your app store and you can download an app on your phone. Can I download a model of, again, let's say heat map of Oklahoma, and then download a model of urban planning and how to combine these together in a meaningful way to be able to start making some complex decisions. And since these complex systems can be thought of as networks, what are techniques that need to be developed to represent these complex networks to stakeholders. So visual analytics was always designed, well, not always, but some functions of visual analytics are designed to work with stakeholders and policymakers to help improve better decisions. But now you have these cascading effects in these complex networks. How do we help people understand that making a policy decision here, what's that going to affect downstream? And with one model, you can't do it. You may have a model for food, you may have a model for energy, you may have a model for water. All these have interconnections between those. So if you make a policy decision for reducing water in one space, you may reduce energy in another space, causing cascading effects across the model that your policymaker needs to be aware of. And then Sylvia talked nicely about this, but data is still hard. Even though we have tons and tons of data, it's noisy. You'll see tons of visual analytics papers over the years on how do we improve labeling, how do we do interactive assisted labeling, and manual data curation and labeling is still very common. You can see things like the Global Terrorism Database and the Armed Conflict Location Event Database. These are political scientists that are paid to hand code these sorts of events and create them in a database. And a really interesting example of this for data wrangling is the Federal Communications data set for spatial broadband. And some data sets are complicated because of policy changes. So from 1995 to 2000, the FCC had a particular set of mechanisms for defining broadband communication measures in the US. In 2000, that changed. Then the census comes and the spatial units change that these are measured on. So now you have to align these policy changes, these spatial unit changes, and these temporal changes across a data set just so you can start even asking questions about broadband in the US. And the reason you might want to ask about broadband in the US is to see if people are being disadvantaged and living in neighborhoods where they don't have access to broadband. So from my side, I think all of the challenges that people listed are really exciting. This idea of guidance, and then that ties directly into provenance of how do we capture information to give people guidance? How do we explain these processes? And then how do we evaluate whether that guidance was good? How do I evaluate whether the system that I put together is good when I only have one user? And essentially it's sort of like going from an Abacus to your TI-85 where, yeah, of course the TI-85 is better, but could there be something else? And it's hard when you're looking at that limited space sometimes. So those are the things that I've been thinking about with this panel. I'm excited to hear the questions and comments from my fellow panelists. Thank you.
So thank you, Professor Maczewski. So I think we can probably build the data of visual analytics, how collecting data sets on how people are using visual analytics system to use those provenance data to improve our workflow. And you are not the last one. So next we will welcome our last panelist, Dr. Henrik Strobert, who is currently the explainability lead at the MIT IBM Watson AI Lab and the research scientist at IBM Research. His recent research is on visualization for and human collaboration with AI models to foster explainability and intuition. His research is applied to tasks in machine learning, in natural language processing, in biomedical domain, and in chemistry. Henrik has served in program community and organization communities for IEEE, EuroVis, VisAI, ICO, ICML, NITS, and is currently the general co-chair of IEEE. Let's welcome.
Thank you. I think I can repeat the first sentence from Ross, saying like, if you are the last one, you probably repeat some of the stuff that was said before, but hopefully I can contradict a little bit of the stuff that was said before and hopefully also bring in some provocation, mainly in form of questions that I asked myself. So when I look at my work recently, I actually figured, even when we talk about visual analytics, I think we are really talking more about interactive analytics than really about visual encoding, etc. Because when I look at myself, I'm using pretty simple visual encodings these days, but I really spend a lot of time thinking about how would a user interact with this? How would the user use my system that I'm coding to come up with new insights, to formulate hypotheses. So maybe we should rename the field and say, this is interactive analytics. The other question that came to mind is, we often talk about generalization, and of course we want our tools to be used, and we want the wide audience to use them, which is good, and I think this is a nice goal. On the other hand, I talked to some friends of mine, and they said, like, you know what? I think it was Fred Homan. He said, like, I created a visualization for 3 people, but these 3 people were flying to the moon. Yeah, so it was a very specific visualization, but yet pretty an impactful visualization. Yeah, so what is the right trade-off here? Again, I'm a pretty big proponent for more general ideas, but specific ideas have to live as well. And so, I mean, this is a common joke if you talk about visual encoding. Yeah, like, oh, this is nice, but have you tried a bar chart before? So, but when we go a step further now, and we talk about implementation, maybe the question of the future should then be, nice, have you tried to make it a Jupyter or R extension? Yeah. So is it always necessary that we start from the ground, that we start creating these encapsulated systems, or should we just use what people in practice actually already use and plug our stuff into it to make it more useful for others? Yeah. Again, this requires some work. This requires extra work. And then this point actually gets really close to my heart is, how do we value open source contribution as a research community? Yeah, quite often, and let me get to my notes here a little bit. Quite often when we talk about visual analytics systems, etc., it's done by the paper. Yeah, the paper is out, and then you do not get any benefit, or maybe your advisor doesn't even allow you to continue working on this until you have a reasonable open source thing out. Yeah, so the question is, can we find some kind of value system and we say, spend a week or 2 to create a tool that actually people can use afterwards? Yeah. Also, how can we kind of prevent reinventing the wheel? Yeah, can we award people to implement the wheel for us? Just to give you an example, there's a lot of discussion about progressive analytics. And this is intrinsically hard to create a progressive system, yeah, that kind of talks from back end to front end, etc. But some core principle is very reusable. Yeah. So the question is, how do we reward the person who will help us creating at least a connection for a progressive system between backend and front end? I don't know. There used to be a demo track at Viz. I don't know where it appeared, but it definitely is not there anymore. Another point I wanted to make is, and this is probably closer to the work I'm currently doing, I didn't want to call it VA 2.2 something, maybe 1.1. Yeah, let's start nimble. I would call it is definitely the tool for higher order statistics that is supported by machine learning. And what I mean by this is, we all know statistics from school, yeah, and it's like median and average, etc., etc. So these kind of simple statistics that still are very helpful and very useful. But now we have these kind of crazy thingies that can learn about data distributions. Yeah, and they are called machine learning models or deep learning models, or however you call them. And they learn about, yeah, as I said before, about data distributions, which is cool. Now you can use them to create new data items of the same distribution, but you didn't gain anything. Yeah, now and the model knows about the distribution, but you don't. Yeah, and I think one of the ways forward is that visual analytics can be a very, very powerful tool to help extracting the information that the model has learned about your data from, to extract it from this model. Quick example here. So we worked with some friends of ours who are in the chemistry department. We trained a machine learning model on chemical reactions that you can express as strings. We adapted or created a visual analytics tool to look into the machine learning model, into the attention heads of a transformer model, of a Roberta model, and gave it to them. Say like, here, okay, we adapted. We also show you what part is looking to what in a very nice rendering, as you see here in the middle, as a like reaction rendering. And they were playing around with it, and they figured, holy moly, one of these attention heads actually learned a function called atom mapping, which is essentially tracking an atom from the left side of the reaction to the right side of the reaction. And while this looks like fun for us, this was actually pretty revolutionary for chemistry, because people were writing heuristics since 40 years for exactly the same problem. And with a little bit of a trick on top, we were able to achieve 99.8 something percent of state of the art. And we just trained a machine learning model. We were able to release it open source. Hopefully we didn't put any companies out of business, but this is definitely stuff that's really cool, really interesting. For me, it's, I think, my favorite success story so far because it was a completely unexpected outcome. These are rare, and of course, they are not published at this. So the other question is a paper really the maximum of relevance for visual analytics systems? Yeah, and we, to a certain degree, you see it with the COVID dashboard. Of course, you try to publish it, but at the end, if there are 1,000 people or news reporters or medical people use it, whatever. Yeah, like the paper might not be the most important thing you've done in your life. And with this, I think I want to close and hopefully open up a discussion.
So thank you, and I think next we will move to the Q&A session. And I would appreciate if you post your questions in the online Slido platform so that we can better moderate and arrange. And until now, I think we already get 9 questions on Slido. And yes, yes, please. No worries. Yes.
Give it a second. Just 1 sec.
Oh, he's controlling.
Test. Okay. So I want to play a little bit of a contrarian role, and I want to ask this question because I feel like a lot of the presentations are, I don't want to say conflating different things, but they're mixing two thoughts I've struggled with for a while. And the question is the question is about whether as a community we're developing tools or are we delivering insights? So I had a long conversation with Jorn about this last night. And I want to actually do a quick survey, right? So how many people here have built visual analytics systems for domain clients? Okay, so when you deliver these systems to clients, do they want your tool or do they want insight about their data/problem? If your experience is that they want your tool, please raise your hand. If your experience is that they want insight about their data, please raise your hand. Okay, so I've also had a mixed experience with this, and I've been struggling with this, that most of my experience is that the clients want the insight. They don't really give a shit about your tool. But when we evaluate these tools, we're evaluating them as if it's like, oh, can this domain expert use my system? And it makes no sense because they don't really care about using their system. They just want to figure out what's in their data. And as a community, we don't recognize that. So every paper we read is about evaluation with domain experts. And it actually just fundamentally is not what I have done, but that's what we're required to write in a paper, as if the delivering of this artifact, this software artifact, is so important, which in my experience, it hasn't been. So when we talk about all these, I feel like there's a conflating of things where we're talking about the tool or are we talking about the insight, and we kind of talk about them all together, but I do think that they should be separate.
So how do you get the insight without the tool?
No, it's not that you can't get the insight about the tool, but it's that who is your real user in this case?
Sure.
Right.
So if I take the example of the Corona data, of course they wanted the tool and it's being used by them because there is not an insight that you can say you're done because it changes over time. It's always new data and they need the tool for daily exploration of what is going on. Is there a new trend? Is there kind of, like you would immediately see if like more younger people die or whatever. You would see that very soon after it happens. And you could really take kind of serious measures if that were to happen. And so it's not a single insight, but it's a tool that you use every day. And that's what is being done. There are people using it every day in certain counties. would be even better if more people were be using it, especially the politicians and the decision makers. Then they would know what's going on.
I think the other interesting thing that's really hard there is it's really hard to measure insights. So having a metric on quality of insights or number of insights generated or those things can be tricky. This is why the BAST challenge was really successful early on, as we sort of had these benchmark data sets for saying, let's develop a tool and see how many of these, let's say, anomalies, which would correlate to insights, might be. But that makes it a trickier evaluation process, which is really interesting, though, for visualization and visual analytics. How do I determine, did this tool help me make better insights? Did this tool help me make more insights? But if I make one multi-million-dollar insight, that is more than enough. But there's no sort of benchmark metric that I can pull to say, number of insights per time spent with the tool or something. And that would be really hard for different problems as well. So I think it becomes a weird, and I think this is why this gets conflated too.
I don't really understand what the word insight really means. And I think some of colleagues define that. And we once had a paper be conditionally accepted, and the reviewer asked, could you ask a domain expert to say what insight did they get from the visual analytic tools you have? And it happened to be the biologist. And we asked the biologist, sort of a look at the review. The biologist said, we don't get the insight every day. We get the insight probably luckily every 5 years. And how dare you guys want to take the credit?
Yeah, so I think I get a bunch of questions. So 3 questions are asking one problem, which is a complexity. Means that, for example, asking VA systems are getting too complicated. How can we encourage researchers or designers to make simpler systems? Usage scenario and expert studies often show that complicated systems are good as long as they give some insight. Do we need new evaluation methods that favor simpler systems? So I will throw the question to Professor Shiva Misha first, because she first talked about the complexity and the guidance. Oops. Or maybe other panelists want to take up this question.
Oh, sorry.
I think you didn't get the question.
Xavier, should we repeat the question?
Yes, sorry, I didn't hear the question.
So the question is that how can we encourage researchers and designers to make simpler systems? Do we need new evaluation methods that favor simpler systems?
I don't think that our aim is to develop complex systems. Yeah? Our aim is that we try to support the overall process of gaining insights, I would call it. Yeah? Therefore, I think I am a fan of simple systems who can solve a particular task. Yeah?
Yeah. I also think we should value simplicity more. So I think quite often when there we are in the paper space again, when you submit a system that has a pretty simple encoding and a pretty simple interaction, but you can show that it actually, and that comes back to your question, that it solves the task, and you can show that it solves the task, we should be very open to accept this as a contribution. While I have, at least in my observation, the impression that the more multiple linked views you should have these days, the higher your chances to get the paper accepted. Yeah, so I really like this question, and I think it should be also a call to say maybe simplicity is worth quite a lot.
Sorry, I'm hijacking this again. But right, I totally agree with that statement. I think there's a notion that when we build software, it's supposed to last for a long time because lots and lots of people can reuse it, and that's baked into Van Wyck's, value of visualization type of thing. But I don't, as I get older, I start to disagree with that more because it's that the one-time discovery can be the thing that breaks the bottleneck, right? That this Hendrik, like your example, you just need that one discovery and it changes the world. And in that case, your visualization might be used exactly once, and the whole system gets thrown out. And I feel like as a community, we should be saying, that's great, that's okay, as opposed to saying, oh, here's a paper I'm going to write that talks about the generalization of like, how well the system can be used by everybody. It's like, it's kind of mixing those goals, and that leads to papers trying to be what they might not need to be.
I have to disagree here. Sorry. I think we are not aiming for generalization. Yeah? This is not what we are aiming for. Yeah? We are aiming for that we are solving particular complex real-world problems with particular visual analytic solutions. I don't think that generalization should be our final goal, because we don't want to design a new Tableau or a new Excel visualization. This is not what we are aiming for. We really want to design visual analytics according to particular data we have available, particular user we have available, and a particular task we have. Or you would call it hypothesis.
So my view is that our main role as a community, okay, not necessarily in the individual cases, is to look at the domain experts' current workflow or technology tools they have, and identify the weakness in the current workflow, whether it is the data don't keep it very well, so there's no provenance, or whether the quality of data is bad, they can't draw conclusion easily, whether they don't have efficient, effective visualization. So they have to read the data in text or in other form, or they don't have an adequate algorithm to sort the data in the right form, and they have to visualize too much data, but they can't work out exactly is. So our job is just like a doctor to diagnose the problem and try to find the solution and improve it. If we are lucky, or occasionally one of the scientists discover something great, and you may call the insight, which is otherwise called deep understanding, according to the dictionary. And then, yes, of course, we will be happy to congratulate scientists, in many ways, or congratulate ourselves. But in reality, for scientists to make such a gigantic step forward, their knowledge play much more role than the individual visualization can help.
Well, and maybe I can ask the rest of the panelists too, is part of this movement we're seeing towards more complex visualization just simply a function of people getting more comfortable with these visual analytics systems over time? When you start out and they say, here's my data, they have some ideas of questions they want to ask the data. You build them a nice system that answers those simple questions, but then they start saying how powerful that is, and they say, okay, what about these new features and these ones and these ones? And as we get further along in time, our user base may be very comfortable with the complex system because they've been learning as the development goes too. Of course, this offers opportunities for guidance where you might have novice users that want to come in and bootstrap up to these complex systems. If you take a look at some common analytic software like Esri or Jump, those look really scary too, but people use those every day in the field. And they have lots and lots of functions and features. So it is an interesting trade-off, and how to measure this complexity versus insight versus usability feature is really interesting. So I don't know if that.
Right. So it's oh, so wait, we have an online audience as well.
So just to push back against what Remco and Vincent said, right? So one difference, right, we are kind of like doctors, but one difference is if I go to a doctor and I say I have a headache, they give me some Advil, whereas if I go to a visual analytics expert and say I have a data problem, they say I will spend 4 grad students and 2 years on it and we'll write a paper, right? Like you're building a new thing over time, and I think maybe one of our objectives should be to put ourselves out of business, right? Every time we build something, we should learn about new things, and now it's not a novel problem anymore, and now the next person has to solve it, has to do way less thinking. And eventually, sure, it's complex, but anyone can do it in the same way that you don't need to be a PhD to build a website or to use social media or do any of the other things that are ultimately complex, but that we have engineered good systems around.
Yeah, I actually completely agree. So first, when I approach domain scientists, quite often they say like, "Oh, can you make this visualization for me?" And then I have to kind of reset them and say like, "Nah, tell me about the problem. Let me take care of how we encode this." But in terms of where I think my mental picture of our community is essentially more like we are building microscopes. So we will never win the Nobel Prize, but we might as well build a microscope that helps you discover the Nobel Prize or the Nobel Prize insight. In addition to this, I think we built the Rolls-Royce of microscopes. So we built a very individualized version for a very individualized task, which is an actual problem, I think. And I very much agree with the sentiment that our goal should be that our tool should become irrelevant at some point, because you might be able to either confirm the hypothesis was made with it, or to reject it, or to automate whatever you just did in a visual way.
Thank you very much for your question. I'm not sure whether you heard my grand challenge. That was exactly for this problem.
Okay, so next we have some question about our review progress, I think. So, one people is asking, the current evaluation on VA system papers are based on standards of InfoVis, assuming Chi-style user evaluation. And this actually killed many good papers. For example, the CoronaVis from Professor Daniel Kim's presentation. And how can we really solve this problem?
My grand challenge is solve that problem.
Yeah, I don't see a good way of solving it. Currently, the best thing is you include a fake user study. I mean, not a fake, but a real user study that does a little twist on it. And the chances really get higher. I can assure you, the chances get higher because you may have a reviewer that appreciates that little user study, even though it doesn't help you to evaluate the system. And personally, I don't think it's a good idea. Same thing with simplicity. You get higher chances to get accepted if you make it more complex, unnecessarily complex for solving the task. If you just use bar charts, even though they may be better, you won't get it accepted. And so like there is a little kind of twist here. I don't know. So what I challenge my students always with, can you solve the same thing with like half an hour working with Tableau?
Yeah.
And there are a lot of tasks that you can, which is great because we have really contributed as a community, a big problem-solving tool that covers a lot of the space of possibilities. And we shouldn't accept, of course, papers that you can do with half an hour Tableau, because that is done. That is not really a contribution then. But I guess even, I haven't checked, but even at this conference, you may find some papers that you could do probably with similar accuracy and performance solved by using Tableau or whatever other tool. I'm not advertising Tableau here. I'm just, it may be GMP, take whatever. Right? A standard tool where you can do quite sophisticated link views with quite little effort. Of course, I'm not saying they can solve all problems. No, by no means. There are enough complex problems where we can't do it. But the space of what we can do with these systems has increased over the years, quite a bit. And it's like, so I'm really, I think reviewers may have to rethink on how they evaluate. Simplicity should be a positive thing and not a negative. Usually if it's simple, you say, oh, there's not a real contribution. Go on, right? And simplicity may be a value because it's more useful, more people will use it, it will have more impact. But that is not on the criterion list as being positive.
So meanwhile, thank you to our supporters of the conference. Tableau is one of them. No, No, what I think what is another problem is, especially for the systems that have public recognition, etc., what you would need to make it impactful and probably put it into a conference is also time. Yeah, you want to do probably longitudinal studies, how people used it, what insights they gained. And quite often this contradicts with relatively short, like, publication cycles, PhD cycles, etc. So the holy grail would probably be to have a longitudinal study in a short time, which is unsolvable, of course.
So sorry for coming again. I really would like sort of other panels to contribute more. But so if you were a doctor and you treat a patient and then you go to your review, which is the audit, to check whether your treatment is good or bad, and you describe what symptoms you see and what causes you analyze, what possible medicine you may prescribe, and you decide to choose medicine A rather than medicine C, and what's the decision, and what sort of side effect coming out. You send to another expert look at that makes sense, it's good. If it's not, as an expert contributes, say, you should choose C, see where best remedy C may be better. And that exactly is the process we should do. We should document our solution provided to our users. We document the symptoms, we document that. And the reviewer, hopefully in most cases, can do that. In fact, my students wrote that process for his visual analytic system. I appreciate, I'm not criticizing the reviewer. Reviewers said, oh, it's a new approach to it, but we're not 100% sure this is correct. And I asked my student to get a domain expert's feedback. And in order to get a paper accepted, my student did it. So that's the current situation. But I'm hoping in the future, this is sort of the symptom, cause, remedy, and side effect analysis may be good enough.
Sylvia, did you have anything you wanted to add? I'm sorry, I think we always, you get left out maybe sometimes.
Thank you, Ross. What I would like to mention is, I think we need new methods for evaluating our systems, because we are not evaluating. We shouldn't only evaluate the visual cues or the visual stuff. We should really support the overall, evaluating the overall process, the workflow, and how it is supporting us. I think we are using the wrong evaluation strategies or methods to show the benefits of our contributions. And I don't think what Daniel was mentioning, we need another user study. This doesn't solve it, but we need really to think carefully what we want to achieve and how we can really evaluate the processes. That's my point.
Can I challenge the panelists to write either a viewpoint or something like that that says, how should we evaluate visual analytics systems papers? So that otherwise it's too scary as a reviewer to say, oh, well, I'm going to buck the trend and start accepting these extremely simple looking visualization systems that are very effective. Because right now the current practice is not that. So it's almost like we need some sort of clearly stated article so that we can all follow suit, right? Daniel, I'm looking at you. I think you should go write a paper.
Yeah, it's difficult to write paper because it's very hard to evaluate. And there are different ways of doing it. Like the take up in the community, how many people are actually using it, trying to find out how much they've got insights out of it, which we already discussed, is difficult. Because a one-time insight may be more worthwhile than kind of like an everyday thing. And then there are so many different systems, so many different data sets with so many wide variety of tasks that are involved with them. So it's kind of, I think, a very complex thing to write, oh, this is how you evaluate the system. It's a whole set of methods and a whole set of things where I don't know the answer to all different versions.
You will need to use this study.
I just, I didn't say maybe Sylvia misunderstood. I wasn't suggesting it. I was just saying you increase your chances. Whether this is useful, I doubt, right, for complex system.
Yeah, but if you have the wrong reviewers that won't like your user study, because you had the wrong users, I think this is not the way how we solve this problem.
What if we introduce the new Tableau evaluation? Every visual analytics system has to say how long it takes to do this in Tableau.
I think it's better that we try to define heuristics, yeah, and to define the heuristics for our visual analytics solutions, and then use these heuristics to test them. Yeah. Like the ISD from Wall is doing it for the visual cues, or something like this. I think we need to be creative. There is a workshop about belief who thinks about different kind of evaluation techniques.
But what about if this is not like how to evaluate visual analytics systems, but a guideline for reviewers to review visual analytics papers?
Sure.
This doesn't work out. This we did in the past. We trained them. This doesn't work. We need, Remco, we need another idea.
Well, I mean, maybe visual analytics systems fall into that category of, the judge saying, what's pornography? Well, I know it when I see it. And maybe sometimes that's also, this is a good way to evaluate that particular system. And it's hard sometimes to have a blanket, one evaluation size fits all. And it's really hard with some of these visual analytics systems where you have built a very specialized tool for one end user to be able to do a very robust user study sometimes.
Maybe it's related to a question that's also in Slido, which says like, what are the different types of contributions for VA? So what are these? Someone wants to start?
I think I would like get a Patrick to get a chance to come in.
Well, we also want to give a chance to the online participants.
Oh, sorry, I think this wasn't online. Oh, okay.
Red, so probably batteries. Yeah, I was going to say exactly what you just mentioned. What I'm really missing is discussions on what is a VA?
Just come here.
What is a VA contribution, right? I think you can't expect to build a system, spend a lot of time on it, and have a paper, right? There needs to be some new intellectual contribution with it, and you need to be able to express it.
Can you speak in a microphone, please? I don't hear you.
The battery is dead. It's turning off every 5 seconds.
There needs to be a new type of visualization or a new type of contribution, not just a system. Did I get that summarized, Petra?
Yes.
Yeah. Okay.
My feeling is that if we take the approach that Min was suggesting, then we look at the whole workflow, then it may be a contribution that is not really a visual contribution that helps the scientist most. And then it's very hard to kind of come in here, right? If you improve the workflow, you can do that, but it may not be visual, or it may be simple visualization. So you may have solved the problem, but you have built a visual analytics system, or maybe not a visual analytics system, maybe a workflow support for this particular application. So if you really take the approach that Min was suggesting, the answer may sometimes automated part will solve it, or data wrangling will solve it, or whatever. Like there may be multiple components along the pipeline, and visual may be just necessary to publish it here. And that, of course, would be a result that we can't publish in this community. And that happens.
Visual analytics also has 6 areas in the area model. There are series of visual analytics that would be required the criteria for the theory. There would be empirical studies for visual analytics, particularly interested in the user's cognitive ability in solving the problem and the skills. That should be that. And there will be algorithms for transform data, and there will be area 5. And the visual analytics, the area 6 itself will concentrate on how to integrate systems from algorithms, statistics, visualization, interaction to optimize it. If, as Daniel said, in some cases, introduce more interaction is more important, then that should be part of the paper as well for area 6.
I completely agree. And so sort of what I'm hearing, and maybe that's not what you're saying, but what I'm hearing is that all the VA papers should go to the applications area, right? And then we need that was what one of these questions about. Then we can do an usability evaluation, and I increase my chances of my paper accepted, and then it's good. But really, yeah, I agree with you, Min. There's so many other things, and you can evaluate all of these different contributions, and you need to have a dedicated thing, but that is very related to the contribution type, right? And that's what a bit what I was missing.
I think I answered your question, but tomorrow I will do a paper presentation on what rejects research on VA system. So I will discuss what are the existing contribution types of VA system. So please check the talk. And I think we can have a last question. And what does Professor Rose mean by explainable visual analytics? So I think many people are really interested in this topic.
You know, sometimes you just put words together to see what happens. So with explainable AI, we're trying to explain why the machine learning model comes to this process and conclusion. And I think with visual analytics, we have this we have this analytical process where we're trying to gain insight. And how can we explain this process flow that we got to this particular insight? And if we're able to explain these sorts of process flows, can we find similar process flows across different domains and be able to track these sorts of things? And I don't know that I have a clear definition of this. This is just some of the things that I was thinking about when I was starting to work on this. But we often have these, there was the nice paper on the branching paths, on thinking about how to compare different hypotheses and how do we fork the garden of forking paths and all these things. So how do we explain the path choices we took? How do we explain these analytic processes? A lot of this tracks back to old provenance work and visualization. So if people were expecting a really strong definition, I don't have one yet, but it was just sort of stuff that I was thinking about how do we explain these processes and insights that we're trying to generate from these systems.
And I would like to add that it's closely related to what Sylvia brought in as what we call guidance.
Absolutely.
Because if you have guidance, you know why. And so it's like, it's closely connected.
Maybe. Sorry.
Yeah, I think we are all good. So sorry, we are slightly out of time. So thank you for our panelists for our very insightful discussion today. And also thanks for all the attendees for your engagement and discussions. We do hope that our panel open up some discussions on how can we make the research on VA system move forward more rigorously and more vibrantly. Thank you, and see you next year in Melbourne. Thank you.
Thank you. Bye-bye.
And since Tableau was already multiple times mentioned, in this room in 3 to 4 minutes, there will be an Ask Me Anything Ask Me Anything session with Dr. Vidya Sadlur from Tableau. So if you want to stick around, have fun. There was an